This is Unit 5, video 9.5, practice with empirical formula. So if we've got empirical formula, we can determine a lot of different things, or we can use the concept of empirical formula to determine a compound if we know percent mass. And sometimes it might be a little more complicated. For instance, let's determine the unknown element in this compound, something Cl4. We don't know what this element is. If chlorine is 83.5% of the compound's mass. So we're going to determine, and the way we're going to do that is find out the missing molar mass. Then we'll go to the periodic table and figure out what the element is. Okay, so XCl4, we're going to go through, we got 83.5% chlorine. So we know we can assume 100 gram sample. If we have a 100 gram sample, then the chlorine must weigh 83.5 grams. That means the other element is 16.5 grams. This is our unknown. Well, we can convert this into moles by dividing by the molar mass of chlorine, 35.45. We do that, we will get 2.36 moles of chlorine. Now, the most important part of this entire thing is recognizing what this number means. This means there's 4 moles of chlorine in the compound for every 1 mole of X. So X's moles, or particles, must be 1/4 of chlorine. So we're going to multiply this, because every mole of X is 4 moles of Cl. We want moles of X. Plug that into the calculator, and we get 0.589. moles of X. So, we don't know X's molar mass, but we do know how many moles are present. That tells us the number of particles. So we're going to come back over here and say, okay, our normal calculation would be to multiply this by 1 mole over the atomic mass. Now that's our unknown. I'm not going to put X there because that kind of confuses since I've used X here. I'm going to put Y here. So 16.5, 1 over Y equals 0.589 moles of our unknown X. Well, now I can multiply through by Y. I'll have 16.5 equals 0.589 Y. Divide by 0.589 and Y equals 28.02. Say, okay, what am I going to do with 28.02? Well, I'm going to go over to the periodic table. And I go over to the periodic table now, and I'll search for that atomic mass. And I say, okay, 28.02, where's the atomic mass? Well, the closest element to that is silicon at 28.09. So obviously the missing element is silicon, 28.09. So I come back and I say, all right, now I know what the formula is. It's SiCl4. So I figured out that empirical formula. All right, let's do a similar problem where we know all the elements in this case. So we're going to determine the compound for KBROX. Well, there's lots of KBROs because there's 4 polyatomic ions that involve Br and O. So it could be BRO, BRO2, BRO3, BRO4. So we're going to figure out which one of these it is. The bromine is 47.8% of the compound's mass. So we have bromine 47.8. The tricky part is now the extra part, the 52.2, is not just one element. It's both potassium and oxygen. So we've got to be able to handle that. So we say, okay, 47.8 grams of bromine. Then we have 52.2 grams of both K and O. Well, we can at least convert this into moles. We cannot convert this into moles because we don't know what proportion is K and what proportion is O. But we'll come back and figure this out. So let's get our Br into moles. We know 1 mole is 79.9 grams. So that's going to give me the moles of Br. Moles of Br are 0.598 moles of Br. Well, one thing we do know, K is 1, Br is 1. So however many moles, not mass, but moles, however many moles of Br there are present, there must be an equal number of moles of K. It has to be. So this equals 0.598 moles of K. Well, we can figure out how much that weighs. So let's go through. 39.10 grams per mole. Plug that in the calculator. 0.598 times 39.1, and we're going to get 23.4 grams of potassium. So now I know what proportion of my KNO is actually potassium. So I subtract 23.4 grams. That gives me 28.8 grams of oxygen. So let's stop for a second and look at what we know. We know the moles of Br, we know the moles of K. I can get this empirical formula if I can get moles of O. So let's calculate the moles of O. We've got 28.8 grams of oxygen. Every mole of oxygen is 16 grams. Again, in a compound, we're talking about elemental oxygen as individual atoms. So it wouldn't be O2, it would just be O. And O2 is when it's a free, separate compound. So we go through and do this calculation. Our moles here are going to be 1.80. So I have moles of Br, moles of K, moles of O. You know, at this point, we divide through by the smallest number. 0.598, 0.598. Well, we know these are 1. We already know that from the formula here, KBr, 1Br, 1K. So we're going to divide this by 0.598. We do, we get 3, and so our compound is KBrO3.